Hi there, I'm Andrew Brown. Welcome to Real-Time Music and Sound with Pure Data. In this video we're going to be looking at the low-pass gate. The low-pass gate has been made famous because of its inclusion in the Buchla series and other synthesizers from the 1970s and onwards. It's effectively an envelope generator, amplitude envelope generator, but it uses a low pass filter in order to mask out the sound. So it has the same function in many cases as a amplitude envelope, but in addition to changing the amplitude, it also correlates that with a change in timbre because you're using a low pass gate to let through frequencies or to obstruct them. One of the Buchlas that early on included this is shown here in this diagram, the Buchla 200. And the envelope shape that we're going to be emulating is shown on the diagram as well. We'll have an attack and a release and a period in the center where when we hold down some kind of trigger, then we open that up. So this notion of a gate is to open and close the signal, let it through and stop it. And we use a low-pass filter in order to achieve that result. So let's have a look at doing this in Pure Data. To do that, of course, one of the things we need primarily is a low-pass filter. So I'll use the VCF filter in PD, which requires a resonance amount, and we'll give it a very small amount because we don't really want to feature resonance. And then, as per normal, we'll give it a volume control and a DAC output. So there's volume, and we'll make sure we can control that volume. The number box. And that number box will go from 0 to 1, give it a label. Alright, so the outputs of our filter go in here. With VCF, it doesn't hurt to include both of those outputs. And then we can turn the volume up very, very slightly. But of course we need a source of some signal, and for this very simple case, we'll just use noise as our input. Okay, so that's all fine, but at the present time the filter doesn't have any cutoff, or at least its cutoff is set to 0. So what we would need to do is to control that cutoff with an envelope. And in PD, whenever we want to do some kind of envelope, the V-line is a good option for us. So we can plug that into the cutoff frequency and send that V-line a message. So now we need to describe our envelope. So our attack, we will go up to what, let's say 3000 Hertz as a cutoff frequency. We'll do that pretty quickly, maybe over 50 milliseconds without any delay. Then our release will go to 0. We might take 400 milliseconds to do that. And if we wait, let's say 200 milliseconds, that will give us the 50 milliseconds of the attack time, which will hold for 150 milliseconds, and then it will start its release. So we can put that in there, and let's see if we magic. We can turn that volume up a little bit further. And so you can hear that as the envelope, the filter rather, is opened and closed, then it lets the sound through and stops it. The nice thing about this as a way of controlling amplitude indirectly via filtering is that it's not dissimilar to what happens in many acoustic instruments. If we take a piano, for example, when you strike the piano key, at the start the sound is loud, from the attack. It's also bright in timbre, and over time the volume decreases as well as the timbre gets more mellow. So this combining of amplitude and filter into the one kind of envelope shape is kind of fairly close to many acoustic sounds, and so that's why it works quite well. In some low pass gates there is also an amplitude control with the same envelope, so that can be done but doesn't seem necessary in this case. So if the information about a low pass gate and how to do it in PD was all you came for, then we're basically done. It's fairly straightforward. The remainder of the video I will elaborate on this, introduce controls for attack and release and frequency cutoff and various things like that. So let's get into our elaboration. In order to look at the next stage, we'll pick a different sound source than noise. Noise was quick and easy for us to get to, but in the spirit of the Buchla, we might use a wave folder as a sound source. So we'll start with an oscillator, and we need to set a frequency for that. So I'm going to grab a horizontal slider for our frequency. Put a number box here so we can see what our frequency is. That will go in. Then we'll set a range, and probably around about 20 Hertz to around 2000 Hertz is sufficient. Give it a title. Okay, so if we plug that in now, it's just going to be a sine wave. Let's see, give it a frequency. Okay, so that's working, but we need to have a much more interesting timbre than a sine wave to make the filter do its thing. So from this sine wave, we're going to add some wave folding math to this. Wave folding kicks in whenever the amplitude goes above sort of maximum, and then the waveform is folded, so we'll need an amplifier. And we want to control that amplifier, so I will put in another H slider, this one to control the amplitude, maybe put it here, and properties, so the amplitude range will be between 0 and 1. Call this the gain. Now we actually need this gain to go above 1, so this is currently going between 0 and 1, we want it to go above 1. And it's also useful to do that whenever we do gain changes, to introduce some exponential like curve. So I'm going to add a power to it to do that curving. We want it actually though to go above 1, so I'm going to multiply it by 2, so it will then go between 1 and 2, but also from 0 to 2, but we need it to go above 1, so we'll offset by 1, and that should give us everything we require. Put a space in there, and into a multiply box. Okay, so now we connect it up. We're still not quite done, but we'll go step by step. We can turn our gain up. Okay, so we've still got that. As we get louder, that's fine. Okay, so that seems to be working okay. We can look within the box here at what our output gain is, and we can see that indeed the lowest value we get is 1, and the highest value we get is 3. So we would normally be distorting, but in this case our VCF is doing some nice work for us to keep the volume under control, and our volume here is of course keeping that down as well. So our volume increase is not yet having any effect because we're not folding, so we will put in an expression tilde box in order to do that. This is covered in detail in another video, so I won't bother going into the details of it now, except to say that whenever it's above 1, we need to fold it back. So, but otherwise we'll just output the signal as it is if it's below 1. Okay, $. Thank you. Cool. So that deals with going above 1, but of course our bipolar oscillator also goes below -1. So we basically need to deal with the values that are less than -1, and the formula is actually very similar. We just need to make the difference between -2 instead. Okay, so frequency is there, our gain is a bit higher. Okay, cool. And you can see, if you have a look at our oscilloscope, you'll see that we're getting some folding in the waveform. And as I increase the gain, we get more and more wave folding, like so. So anyway, that's all in order for us to get some rich signal that we can then apply our low pass gate to. So now what we want to do is to elaborate on our low pass gate itself, in particular to control things like the cutoff frequency and various other things. So I will remove that, and we might start by just putting in another slider to control our cutoff frequency. So this, we're going to basically go from very low up to around about 10,000 hertz will be fine. As for frequency things, typically this range to sound sensible perceptually, we don't want it to be linear, we want it to be logarithmic. So I'll just choose that, and there's our cutoff. We can look at what value that is in there, and then put it into here. So now you'll hear, why is it only 100? That needs to be quite a bit lower than that. Thank you. Okay, so now you can hear that as we change manually our cutoff frequency, we're letting through more or less of the signal. And of course our task is to then put this cutoff change under an envelope control. Okay, so let's get to that. We need to be able to start and stop our envelope. So I'm going to do that by using a key command on my computer keyboard. So with that there, I will select the key. The key I'm going to use is the Z key on my computer keyboard down the bottom left hand corner. I'm using that because I don't use it all that much when I'm programming in PD. There's not too many objects with a Z in them. So as I press that, you can see that's our key. I'm going to copy and paste this for the release trigger, which will be the up. So you'll now see I press Z down, press it up, down, up, down, up, down, up, down, up, and we've got things which I can easily trigger from. So now we need to send values to the frequency cutoff with those triggers. So let me first of all use a float with a fixed value. The reason for the float will become clear a bit later, but mainly it's because we need a stored value that we can trigger from time to time as we need to, but it needs to be variable, unlike a number box. Then that's going to go to a message, and the message is going to be sent to a line object. So This says basically go to maximum volume to 1 in whatever time period is sent in from here. $1's a variable for that. And then we can use a line value to smooth this out. Initial value of 0, and I need it to operate quickly so we get a smooth thing. So just set the recompute time to 1 millisecond. And so that should be fine. So now that's going to turn on. It will never turn off, but I think I can manage to control that. So this line will go from 0 to 1, which is okay, but it's that would be fine if it was an amplitude, but we actually want it to control our cutoff filter, and you can see that our cutoff frequency is much higher than 1. So we need to multiply this value by whatever it is that's coming in here as our cutoff frequency before we pass it in to there. So that will mean that it will go up to whatever our current, so this is our current cutoff frequency. Connect that there, trigger it. Okay, so that does set it to the cutoff frequency. However, I haven't got my release set up yet, so I need to be able to have a manual way of turning this back to 0, and then starting up again with my Z key. But because it's quite a quick attack, it's not really clear that that's happening, so let me just make my attack a little bit longer, and you can hear that we're getting a kind of fade in. So it'll fade up to whatever this cutoff value is. So if I increase my frequency, turn my volume down a little bit, set it to 0, then go Z, and we get a kind of fade in of that frequency cutoff. Okay, 0 again. Okay, so let's deal with actually putting in the release properly. The release will do a very similar thing, so I can copy and paste these over here. And instead of though going to 1, it will basically go down to 0. I can feed that into the line, like so. So now I've got on, and then when I release, I have off. Got on and off. You may notice that I get on the key, I do get the repeat thing, but it's a bit inefficient computationally, but doesn't make a difference to the sound because we're already at that maximum value. So the line is trying to go to that value of 1, but it's already there. So it's effectively works okay. So now I have my trigger up, I can hold it, and then I can release, and we're all good. We can, of course, adjust our times for both the attack and the release. So if I look at the properties of this, let's call it attack, and can range, I don't know, up to 2 seconds or something, be fine. And our release, which probably range a little bit longer, so that's fine. So now I can set my attack, and I can set my release, then play my Z key. So I've got a fairly quick attack and a fairly quick release. I can increase those values, get a longer release. To be even nicer, we'd probably want to make our envelopes exponential rather than linear. Put that in. So that makes them sound like they're shorter, but it's just because it's dropping faster. So if we turn our release up a bit more, we get that there. I'll turn the volume up as well so you can hear it a little louder. I also need to hold the key down long enough for the attack to fully come in. And we can control our cutoff here. And the volume down a bit so it gets brighter and louder. It's part of the issue. We've got these things combined now, brightness and loudness, so I have to manage it all. So there it is. And so this cutoff now controls the maximum cutoff of our low pass gate. The attack and the release control those aspects of it there. And if I wanted to be super complete, then I can have a control over our resonance as well. Let's look at the properties of that. It can go from 0 to 10 or something like that. Will be fine. So we're playing. I increase the resonance a bit more. A bit more. You can hear that we've got a resonant low pass gate in operation here. Anyway, that is plenty of work on the low pass gate. Give it a go. Hope you enjoyed this, and I'll see you in another video.